Good afternoon, and welcome to my session today called Analytics Engineering is Ergonomics for Analysts. I learned these has a later pointer about 20 minutes ago, and I'm going to use it to its full extent. So this talk is focused on what we've done at Eleanor Health in the past year, and how the migration from DBT Cloud combined with migration to DBT Cloud, combined with a major re-architecture effort, made a data environment that increased the efficiency, quality, and speed of our analysts' insight output. So, hi, I'm Scott Parent. I'm Director of Data and Analytics at Eleanor Health. I have about 10 years experience in the data space, and I've led 2 data teams before this one, once in consulting and once in the nonprofit space. 3 of those years have been spent heavily utilizing DBT for analytics engineering, and through that experience, my specialties have turned into data architecture, analytics insights, data visualization, and data strategy. And Eleanor Health is an outpatient addiction treatment program that breaks down the barriers people with substance use disorder face by transforming the quality, delivery, and accessibility of addiction treatment in order to help our members live amazing lives. So I came into Eleanor Health about a year ago today. The first major decision that I made as leader of the data team at Eleanor Health was to migrate from DBT Core to DBT Cloud after having spent about a month of observing how the current architecture was not really supporting our analysts. So we did a successful pilot of a new architecture attempt with our partnerships team at the end of last year. And Q1 and Q2 of this year, we spent all of it re-architecting our data transformation layer, migrated to DBT Cloud, and wrapped up major development in May. So all in, it's about a 9-month effort to go from DBT Core to DBT Cloud with a world-class architecture. To give you an idea of the tech stack we're working with, so source data comes from Athena Health, and it comes from Salesforce. We do our data extraction from Fivetran. We use Google BigQuery and, of course, DBT, the reason why we're all here. And then we visualize in Tableau. So when I came into Eleanor, one of the things that I discovered was there were 3 attempts prior at rebuilding the data architecture that had been abandoned before being finished. But many of those data models that were made for those attempts had actually been shipped to production. So there were situations where business concepts had up to 3 different sources of truth. A kind of brittle data architecture organically grew around these different attempts at re-architecture, along with various point solutions that have been created tactically in order to solve problems as they came up. And it made it very difficult for our analysts, particularly without business requirements to refer to actually put together insights. So we were in a situation where analysts didn't really trust the data, so they were either building all their analytics straight from source data themselves, bypassing the DBT models that existed, or they were Frankensteining together different intermediate models at different points in the pipeline in order to get the specific columns that they were looking for. It wasn't sustainable. It was very difficult and hard on our analysts to consistently put out high-quality insights. And then on top of that, we had hundreds of dashboards, hundreds in mode, that all kind of address similar concepts, but the data models behind it were from the various different re-architectures, so it was difficult to support, and it was hard for our business users to get insights out of that. So our business users were in a spot where they were fending for themselves and doing their best to just get data and put it into Excel to figure out the answer they're looking for. On the analytics engineering side, our analytics engineers had to deal with a highly customized implementation of DBT Core, incredibly difficult to work with. Our development would often get paused for days because our analytics engineers were busy troubleshooting issues with their command line implementation, as opposed to actually thinking about data models and solving data problems. And we didn't even know orchestration either. That was owned by a separate team. So we didn't have a lot of flexibility with the cadence at which things run. Net, it took our engineers about 3 times longer to actually develop new features than it really should have. So this is where DBT Cloud changes the game. Moving to DBT Cloud was a major boon It allowed our analytics engineers to be able to focus their thinking on data problems as opposed to command line and local configuration issues. It also presented me with an opportunity to reset analytics with our stakeholders. So we retired outdated models, we retired outdated metrics and updated their definitions. We focused on making really good dashboards with tight business requirements that served users' needs. And one of the big things I did was I partnered with our stakeholders pretty closely to try to define all of the metrics at Eleanor Health. I used what was called the SOMA framework, Standard Operating Metrics and Analytics, to be able to think through what are all the different things we need to define about a metric in order to build out, all the metric trees and define all the metrics at Eleanor Health, to then work backwards from that to create the right data sources that we need, and then to figure out the right dashboards to serve our stakeholders' needs. Other big win, owning orchestration. We were able to build our models and schedule them the way it worked best for the business, as opposed to a prior arrangement. So on top of that, testing shifted from a nice-to-have to a need-to-have. So we heavily utilized DBT's testing features, hoping to catch any problems before they even made it to production. And really the goal was to make sure that data did not even come into our pipeline unless we were sure it was data we wanted. So this is the final architecture we settled on. So the patterns that we deployed are based on my experiences in about the last decade of building out analytics, both in-house and for clients. And the rest of this presentation is going to be focused on sharing with y'all what these are and why we chose them. All right, and now here are the principles. All right, so here's the first one. Design patterns should always be predictable. When you think about data pipelines, I always imagine them in my head as looking like a river. Rivers have many different sources of data, but it all predictably flows into the same channel. Melted snow from the mountains and groundwater all converge in the water basin before flowing into the ocean. DBT allows us to systematically apply design patterns, or general concepts for solving specific problems, so that we can move our data to the basin of insights effectively. Our pipeline consists of several adapter layers that abstract and synthesize our data so that it can be passed to the next layer, much in the same way that rainfall brings water vapor from the sky into our river system. It also allows us to think about the global and local control when placing out transformations. Transformations that need to be reliably applied to all data can be placed upstream, like damming a river. Whereas transformations using logic specific to only one business domain can be applied closer, much more locally, at the point where insights happen, or right before that. So, the goal is to systematically move our source data through our pipeline to create core entity objects within our data preparation layer. This is the mastered data for a business concept, where a table contains one record per observation, along with all relevant dimensions and measures. And so to get there, data starts at a staging layer I've lost my notes here for a second. Data starts at a staging layer, creating the finalized source data to feed our pipeline. Here we do things like filter test results, apply global assumptions, do any data corrections that haven't been made in the source system, and standardize our field names. The goal is to have one model for each entity table within our source systems. It then moves to our intermediate models, where the data is joined, aggregated, transformed, or unioned to create a final entity table for a concept. This is where data about the same concept, but contained within different systems, can be brought together into the same table. With our tech stack in flux, the design patterns allowed us to bring online new systems of record and normalize them to the existing entity concepts to limit the amount of downstream pipeline redesigning that we would need to do should we choose to bring on board a new system for something we were already doing. Downstream of our core tables, we applied domain and payer-specific business logic in their own intermediate tables. For example, different payer partners have different attribution definitions than the one we use internally at Eleanor. These all feed into our MART tables, designed to be easy for our analysts to use. So we can have a MART table that has the Eleanor definition for attribution, and then we can have a MART table that combines all the different pair definitions as well. So analysts can look at it either way. In addition to that, this data also feeds several recurring report tables, as well as metric summaries, all designed to minimize repeated SQL scripting on behalf of the analysts. Alrighty, moving on. The namesake of the presentation, analytics engineering's primary purpose is to be ergonomics for our analysts. Good data architecture should focus on eliminating as much toil as possible from our analysts so they spend as little time coding. Analysts should be focused on what business problems are worth solving and how to combine clean data to create an analytical model to solve that problem. When data architecture is poorly designed, insight development is costlier from a time and effort perspective for analysts, and it really limits the impact that analysts can have on using data to drive business success. Besides the time cost, it also introduces significant business risk within your analytics organization. Analysts might make a coding error. There might be two different analysts that come to slightly different SQL about how to define a metric, and then you have two different numbers. You might have a situation where an analyst doesn't save their SQL, and now analysis isn't reproducible when an executive stakeholder wants a different take on the analysis or a small change to it. So this business risk, by not solidifying what analysts need to start, is what we're hoping to mitigate by thinking about analytics engineering as ergonomics for them. So how do we do this? Save our analysts as much time as possible. We built the following into our data architecture. First, we organized our data using schema partitions. Analysts knew that all the data that they commonly used is located in the analytics layer schema, whereas all the views that DBT makes that can be useful for analytics engineers are located in the preparation layer schema. The end result is that analysts only need to scroll through about 30 tables, as opposed to 300, to find the right data set for their analysis. The analytics layer also contains MART versions of our core entity tables. Within the MART, we've ensured that confusing names are simplified and then unnecessary columns are removed. We also make sure that if a concept appears on multiple tables, the column name always remains the same. This is especially important for primary and foreign keys. Keys have the same name on every table. The entity name _ID, pretty simple, as opposed to just being ID in the table where that key is the primary key. We also endeavor to put every single relevant foreign key onto a row. And both these things are basically to ensure maximum interoperability across all the different entity tables that we're building. When there are multiple, we package them up into an array so that analysts can have them for referencing and auditing. So if one record is the result of an aggregation, put all of the keys that are a result of the aggregation into one place so that they're able to trace the lineage of that row. Tables also have Boolean fields for business logic that's commonly used in filters for definitions or for grouping. So an example for this, we have is complete or is canceled. There's a couple different statuses on appointments that could basically signify if something is a completed appointment or if it's a canceled appointment. So we just apply that as in the SQL. And then you have a nice, neat dimension called is complete or is canceled as true or false that analysts can just add where is complete or where is canceled equals true to their SQL query, and it's super duper easy for them to get what they're looking for. We create metric summary tables across our most commonly referenced entities, such as summing how many appointments a member has in a month and breaking it out by clinical resource. These are particularly helpful when building data sources that feed Tableau dashboards. And finally, we deployed the RudderStack ID stitching package to stitch together user IDs across multiple systems and created what we call an Eleanor ID to make cross-system joins for the same user easier. Number 3. When I'm building technical systems, I think of them as a collection of capabilities, which is a concept that I borrowed from the enterprise architecture domain. Capabilities are a building block of business logistics that reliably and consistently produces the desired effect. They're pieces of development that can be deployed modularly and recombinantly. Focusing on robust, extensible, and reusable capabilities minimizes rework and increases business agility. Capability is the opposite of point solution, which in the data world is something that would be like cheap, a fast model, purpose-built to solve only a specific problem. They aren't flexible because they're pre-aggregated, or they could employ local business logic, or they really just only answer one question. Well, that is. And then the big problem with architecture that consists solely of point solutions as opposed to capabilities is when your business users are looking for data in order to answer a problem, they might see data that looks similar enough to the problem they're trying to answer that they take it and then attempt to use that in order to solve the problem, but the end result is something that may actually misdirect or mislead them, and they don't actually have the right evidence to make the decision that they need. So the two capabilities we focus on building are entities and activities. I wanted to borrow the strengths from both Kimball and from activity schema when building our architecture. As previously mentioned, an entity is a thing, place, person, object, or concept where one row represents a single indivisible unit of observation. An activity is an interaction between two entities where each row contains the subject, foreign key, and a standardized verb name, and the object foreign key. Focusing on having a robust set of entity tables and activity streams for every major business concept means analysts only need to focus on joining and aggregating the data that fits the analysis. Another tip that's really useful for activity streams and for entities with sequential aspects, such as our appointments, is dimensional indexing. Dimensional indexing is adding a rank value for the order specific rows happen in, such as the first appointment having a value of 1, the third appointment having a value of 3, so on and so forth. And then you can also have dimensional indexing then indexed by dimensions themselves. So we could have one row that's looking at the order of all appointments ever, another row that looks at the order of appointments in a month, so then the rank would restart each month. And this really opens up possibilities for analysts to examine the sequence of data without needing to do any of the partitioning themselves. Alrighty, and then our final one. We took the approach of optimizing for the cognitive load of our engineers, not necessarily system performance. Cognitive load is how many pieces of information an engineer needs to recall in order to complete a task. Our working memories can hold about 7 pieces of information at one time, plus or minus 2. There's not really a lot you can do to increase this number, but I promise you there's a lot you can do to decrease this number. So instead, good developer experience focuses on expanding the breadth of information one can use at any time. There's 2 ways to do this. The first is to write information down and physically reference it instead of holding it in working memory. Works for information that doesn't need to be recalled often, but it also comes at a cost of people needing to look through all their documents, and so it takes either more time or you have to remember which document contains the information you need. The second way to do this is to abstract multiple pieces of information into a single concept, so that the single piece of information in your working memory contains more meaning. This is information that can be unfolded into multiple pieces of information via implication, relationship, or hierarchy if needed. For example, we monitor the volume of all patient-kept appointments or synchronous interactions. That's 2 pieces of information to hold in my working memory and quite a mouthful to say. So instead, we abstracted this by calling everything that fits that definition an encounter. Now, it only takes up one place in my working memory, and that frees up that other spot for other valuable things as I'm developing. So recognize that a lot of what we do to optimize for cognitive load is not the most cost-effective when you're operating with terabytes or petabytes of data. However, the majority of businesses I've worked with and in are really more appropriately considered medium data instead of big data. Thus, the engineering costs far outpace the cloud bill. In these cases, your money goes a lot further helping your engineers code faster and with fewer bugs than it does shaving a few dollars off your cloud bill. So part of the Eleanor architecture, one of the major ways we did this was by thoughtfully using DBT models and CTEs. As opposed to trying to do everything in one big long model, instead we broke our models up into single logical units of transformation whose output can be understood with a descriptive name. Likewise, steps inside each model are descriptively named CTEs that expose the step-by-step process to get your data from input to output. When you do this right, this shifts the analytics engineer's relationship with the pipeline to be not just understanding an abstract set of, or not to be understanding hundreds of individual steps, but instead understanding an abstract set of actions that occurs to your data as the data flows through your pipeline. The river flows down to the basin. I encourage my engineers to not use aliases and instead to be overly verbose when naming anything, whether that be a model, CTE, or a column. It might take longer to write, but it's a lot easier for somebody without context to read. One of my biggest pet peeves, I'm just going to share this right now, single letter aliases. They are so hard to read. Oh my God. Please, please, please don't do this. We also use consistent and predictable naming criteria for our columns. In addition to the previously mentioned techniques of having all columns for a single concept have the same name across all of our tables, and the beautiful thing about this is you can use the user-friendly using command instead of on in order to join different tables together. But we also put information into the column name when useful. So an example of this is that all of our date time columns have a suffix at the end of them representing the time zone. So underscore UTC, underscore EST, so on and so forth. Finally, set SQL standards and automate them. So I personally like SQL that yells at me. So all caps SQL is great, but not everybody in my team codes that way. However, if your SQL is always formatted the same way, everyone can learn to read it faster because the information is going to appear where they expect it. DBT has a native linting feature that's awesome. You can specify exactly how your SQL standards work, and then you hit a button, and then it just makes the SQL look the way it's supposed to look. So this means that my engineers can write however they're most comfortable, and then they hit lint, and then everything in our code base looks the same. It's beautiful. So if you're starting out with setting SQL standards, I usually start with Simon Holywell's SQL Style Guide, linked here. It's called SQLstyle.guide. I brought this SQL Style Guide into 3 different organizations already, and it works really well every time. All right, so the results. Where did this get us? So, as you recall, this is the diagram we looked at the start. By employing predictable design patterns, focusing on analytical ergonomics, creating robust and reusable capabilities, and optimizing for cognitive load, my analytics engineering team and I were able to build a data pipeline that produces high-quality, consistent, and easy-to-use information that helps our analysts do more in a day than we used to do in a week. On top of that, our pipeline is flexible enough to organically grow with our needs and new technologies, minimizing rework and maximizing engineering spend. By the numbers, we have fewer but higher quality models, comprehensive testing, and stable metric definitions. The results speak for themselves. We've had maybe 4 data incidents this year versus the nearly constant stream of firefighting my team was doing when I started. We reduced dashboards from 194 in various states of disrepair to 25 well-supported and informative dashboards. This shift in quality and productivity couldn't have happened if we didn't build on the firm foundation that DBT Cloud provided us. After this transformation, I'm proud to say that at Eleanor Health, we have good data and happy stakeholders. Thank you. And if you want to connect with me on the internet, this is how. Are there questions or comments? Yes, sir.
Yeah, so question, you talked about the firefighting when you joined.
Yep.
So there was probably a point in which you needed to get buy-in and resources to do this big cleanup project. How did you go about kind of expressing the need to do all this and getting buy-in from higher ups and and whoever?
Yeah. So, I mean, I think the normal way people recommend it is like an MVP. I take the philosophy of not an MVP, but a slick, simple, lovable, complete. So find a project that you can do with the process you want, and then make sure that you have something simple, lovable, and complete. You're not going to need to keep reworking when you get buy-in, and then use the momentum from that to get to the next thing, and so on and so forth. Again, going back to my point about capabilities, make sure that your slicks get you a new capability, so that the next thing that you build is easier than the thing before that. And then eventually it just kind of starts, working itself.
One follow-up to that is,
Yep.
what did it happen so subtly that people may have not noticed that things improved overnight? Was it kind of like maybe a couple quarters of incremental improvement, and then all of a sudden we have this kind of compounding
Yeah.
improvement?
Yeah. So like our Q1, we did a lot of planning, and after like the pilot, we had pretty good executive feedback to like sort of slow down to speed up. And then after we finished our planning, got our initial capabilities into production, we started delivering things at a pretty fast rate. And now I'm at a point where like we ship something new every sprint, which is the fastest I think I've put things out in my entire career. Other questions? Yes, sir. You in the back.
Yeah, you mentioned using the SOMA framework
Yes.
earlier. I'm really interested how you leverage that. What was your process? And I know it's like a repo, and it kind of has a lot of different capabilities. So I'm very curious how you leverage that.
So I used Ergus Danabi sent me their spreadsheet for essentially all the different things they need to think about when defining a metric. I customized it a little bit for a use case because there's some things that weren't as relevant. And then I used that to start working through like, okay, I know these are the key metrics. Let's define these here. Okay, go one level under, like what are the, secondary metrics that power these, and then start having conversations, get our analysts to understand how I'm thinking about it, and then have them help fill it out. So now we have that, the metrics I said, the metrics defined there, that's all the metrics in our SOMA document that myself and all the analysts have been adding every time we put something new in Tableau. Other questions? Yes. We'll go with you and then you.
My question is like before the migration, how you guys were doing, orchestration, moving your CI/CD. What was the process looks like, and from the observability side or governance side?
Yeah, I forget the tool we were using to do orchestration. It wasn't like Airflow or anything like that, but it was really rigid. So like you had to kind of like define what you're trying to do, and then it was another team that was managing it. So it's really difficult for us to experiment with like, okay, what can we do? What's the right cadence for this to run in? So I mean, quite frankly, the fact that we don't need to worry about orchestration because dbt Cloud does it all is a huge win. Was there a second part to your question, or did I answer it?
About the observability and the governance.
So observability and governance, I think governance is right now we're just kind of like keeping pretty tight control over what we build. So we make sure that everything has like a distinctive planning and then sign off from stakeholders and then UAT before it goes to production. So you've got a good governance process for that. We're using dbt tests right now for data quality, and I think that as we mature, there may be room for more mature observability solutions. That's one of the things actually that's on my strategic roadmap for 2025 to figure out what will fit. All right.
So my question is also following up on the SOMA framework and the metrics tree. I'm myself a huge fan of that, and I'm trying to implement it in my company. So I'm wondering, like, what kind of approach did you choose for structuring your models in dbt, like in the MARTS layer, and also in Tableau, like sort of how do you group the models? Like, do you group them by department or by some kind of function layer? Because like, I feel like the huge value of metrics tree is to actually be able to understand your building, your business, sort of by not function, but how to say that, but like a segment, to say. So if you could share.
Yeah. Well, yeah, and it's so we took a domain-based approach. So we had 4 domains at our company, and then 1 analyst aligned with each of the domains, so that analyst could just become an expert in that domain. But everything's not that clean because there's lots of domains that like overlap or like are feed into each other. And so those gray areas, the analysts kind of had to work together to figure out how this definition worked. So that wasn't necessarily clear. But the advantage of it was that we had our key, let's call it OGSM metrics that our executive team was watching, which is a list from somewhere between 10 and like 20 metrics, depending on what exactly we're looking at. And then we were able to kind of trace downwards from there. Like, okay, then who's responsible for this metric? What are the inputs to this metric? Does this metric have an input from somebody who is not responsible for that metric? How do we make sure that gets governed? So really just drawing it out, thinking it through. And then it turns out when you like draw everything out and like define everything, it's really easy to kind of find the gap or find the thing that you need to solve for, get it done. Any other questions? In the back. Actually, am I going over? Or? Okay, cool. Last question.
Okay, I was going to say, it sounds like you all have been really successful with just your overall modernization with DBT Cloud, which is super exciting to see.
Yep.
What's next? Like, what any kind of particular features that you're looking to kind of integrate into your workflow, or anything that's kind of supercharged that's top of mind for you all?
Yeah, I think there are. There's definitely more metrics to build out. We're not done. We got all the pieces together, but there's so much more to build. I think semantic layer is one of the things I'm starting to think about now. I played with the semantic layer when it came out, and I realized that it was just going to take a little bit more time to get it going than I had. So we're kind of defining we're defining the metrics in the spreadsheet, then people are building them out in Tableau. So there's opportunity there for, I think, really getting everything programmatically defined. So that, I think, is big on my 2025 roadmap. And then, lots of, deeper analytics. Like, the better foundation you get, that's when you get to start doing cool stuff, right?
Love it. Thanks.
Cool. All right. Well, thank you so much, everybody. I'll be around if you have any other questions. But if not, have a great day.